Air displacement plethysmography is a technique used to determine human body composition. Developed into a viable system in the mid-1990s, plethysmography refers to the measurement of size and, in this case, volume. It is a tool used by doctors, nurses, nutritionists, and athletic trainers to help patients assess their overall health and efficacy of their exercise programs. The only commercial available product that uses this technique is called the BodPod, made by Cosmed, and previously Life measurement instruments. This device has two chambers, one for the patient to sit in and another in the back that is not visible for reference pressures. Physiologically, this technology measures percent lean versus fat by measuring human body volume. This machine uses a densitometric technique that uses air displacement and pre-recorded patient mass to determine body density by solving the equation density equals mass over volume. Mass is determined using a highly accurate scale. Body volume is determined in a 5-minute test when the subject sits inside a chamber and displaces a certain amount of air equal to his or her body volume. The volume of air inside the chamber is calculated by altering the size of the chamber via a diaphragm in the wall between the two chambers and applying relevant physical gas laws to determine the total volume from the changing air pressure within the chamber as its size is altered. By manipulating the pressure with a known initial volume at a constant temperature, Boyle's law can be used to determine the final volume. This law states that the initial pressure multiplied by the initial volume is equal to the final pressure multiplied by the final volume. This means that if volume increases, pressure will decrease, and if volume decreases, pressure will increase. Subtracting the final volume, or volume with the person in the chamber, from the initial volume of the empty chamber, the volume of air displaced can be found, and with this, the individual's body volume. Once body volume is determined, body density can be calculated and inserted into an equation to provide percent fat measurements.
Considering fat and non-fat have different densities, percentage of body fat versus non-fat can be determined. The non-fat components include minerals, protein, and water. In order to complete the calculations, assumptions that fat-free components are the same as the reference standards must be made. Before starting the test, calibrations must be performed. First, the chamber is measured while empty, and then with a 50-liter calibration cylinder inside. 2 measurements are also done while the patient is inside in order to assure accuracy. If these measurements do not agree, a 3rd measurement may be taken. Patients are asked to wear tight-fitting clothing or swimsuits as well as swim caps over their hair in order to minimize air getting trapped. In order to correct for patients' normal breathing, thoracic gas volume is determined by having the patient breathing into a tube and recording pressure changes. Thoracic gas volume is the average volume of air in the lungs during tidal breathing. This process allows for more accurate results. Compared to the previous gold standard of hydrostatic weighing, ADP uses similar engineering principles but with air rather than water. This is advantageous as it prevents the patient from getting wet, making it more user-friendly for younger patients and the elderly.
The BodPod has a seat insert for children between the ages of 2 and 6. However, different software and calibration standards are required. The data remains accurate for children as small as 12 kilograms. The normal calibration works for weights up to 250 kilograms.
Bioelectrical impedance is an electrical solution that also calculates body composition. This particular method measures flow of current between electrodes placed on the body to provide an estimate of body water present to calculate fat. It is advantageous as it is minimally invasive, but is not recommended for those with implanted devices, as the electrical current can interfere with things like pacemakers and internal defibrillators.
In addition, basic skin calipers are a more cost-effective way to determine body composition, as they involve calculating lean body mass by simply measuring the skin fold thickness of the layer of fat just under the skin. Skin calipers, however, lack the accuracy that the air displacement plethysmography with the bod pod supplies due to human error and generalized equations. With that being said, ADP has a high level of accuracy, is easy to use, and has a relatively fast test time. However, it does have some limitations. The commercial bod pod unit is very expensive and ranges in price from $30,000 to $40,000, making it only available to certain facilities. In addition, the manufacturers indicate the general error range of the bod pod is 1 to 2%. In regards to patient-specific limitations, the subject should not have exercised for 2 hours before the test, as hydration status and increases in muscle temperature can adversely affect the results. Nevertheless, air displacement plethysmography in the form of the bod pod is considered to be the current gold standard of body composition measurement.